Now, what does trustworthiness means? In the simplest form, it means, am I able to meet, is the AI system able to meet stakeholder expectations in a verifiable way? So for the sake of discussion, if when I ask the AI system to play a particular song for me of my favorite singer, and it gives me a remix version of that, now that's not trustworthy. That's not what I expected, right? uh, and similarly, other things also, if I'm asking it something and it's not giving an accurate output, so then it's not trustworthy, then the trust level goes down. So other characteristics of trustworthiness include, for instance, accuracy in the output, fairness, transparency. We'll talk about these aspects in a bit. uh, Now, the examples which I've given you maybe are somewhat low stakes. Even if it's not able to give the correct output, fine. But what happens if the AI system has been part of our daily life and is making important decisions for us? So, for example, let's take a real life example here. And this is an AI system deployed by a bank. And you and I are the applicants who are applying for loan. So suppose, for the sake of discussion, there are 1,000 loan applicants to the bank, and the applications are being screened automatically by an AI system. So what do you and I expect? We are the stakeholders. Now, in terms of trustworthiness, we expect that people who are actually credit worthy and are able to pay the loan, repay the loan, they should be granted the loan. And if people who are not credit worthy, they should be moved out of the loan application system. So I'm talking about true positive and true negative here, right? No, but then that's not it. What about people who uh, are not, who are actually credit worthy, but uh, the AI system predicts them as not being credit worthy? So that's false negative. Now, if the AI system has a degree of accuracy and it's not able to predict, obviously it's not able to predict 100% accurately, then what will happen? The people who are actually credit worthy but loan is not approved, they are going to be dissatisfied. So there's a risk of dissatisfaction here. Let's look at the other, which is false positive. So people who are predicted as credit worthy, okay, loan approved for this person, but actually that person may not be credit worthy. Now that's a huge operational risk to the bank, because the probability of default increases here. So you see, because of the element of prediction in an AI model, there is room for error. At best, what we can do is minimize that error. So, and we have to measure that error also. So here we have a formula at the bottom of the slide in terms of accuracy, number of true observations over the number of total observations. So the true observations are, say, around 800 out of the total 1,000 applications, and it has an accuracy of 80%. Maybe you want to increase it to 90, 95%. That's fine, but there'll always be an element of risk, and one has to monitor this. Now, let's look at another aspect of bias in the AI system. Now, what is bias? So bias is a systematic treatment of a particular group of persons in comparison to other. Either you are giving preferential treatment or you are maybe discounting their presence. Either ways, it's bias. And what's the challenge here? The challenge is equal opportunity and inclusivity of all the people. So what could be the types of bias which could creep in to the AI system? The first one is algorithmic bias. What is that? The mathematical functions or the criteria or the parameters on which the programmer of the AI system has built the AI model can itself be biased because of the mindset of the programmer here. I'll give you a very small example here. Yesterday on Teachers' Day, I received some images and photographs, and they're depicting that a disciple is bowing to the teacher, which is absolutely fine. But then most of the images conveyed the teacher as a male person with some kind of a long beard, long hair. Now that's the example of an algorithmic bias, because the person who created that picture or algorithm sees the teacher in a particular way. So algorithmic bias can creep into the system. Then you can have cultural bias, the way the society thinks. So for example, you have a AI screening system for resumes of potential candidates. And the way it has been programmed is that, to prefer resumes of one particular gender, maybe male, and discriminate other genders. Now that's a bias. That's not acceptable. That's against the fundamental rights of people, right? And then you can have representational bias also. So what it means is, now let's take an example of a facial recognition system. All right. And while training the particular AI model, what you've done is you've fed lots of millions of pictures, but those pictures are from a particular region only, say Europe. Now, if that system is deployed in India, do you think it'll be accurate? Maybe no. Why? Because facial expression is very, very unique to various regions. So the AI system is going to become more and more inaccurate and predict inaccurately if that same system, which had only pictures of European population while training it, is used in India or elsewhere in South Asia. So, and then, so what kind of fairness metrics are deployed here? What are we measuring by? So what are the opportunities or considerations for an organization here to minimize the bias? What kind of metrics? The one which I showed you in the last slide is one example of a fairness metric. So what it means is that, look, whatever accuracy is being given by the AI model does not change with demographies from one region to another. And then did we consider the various groups involved? So suppose we have to deploy this facial recognition system in a different region. What percentage of people's images are from that region? Is there richness? What about the diversity of the sample size? And what about the evenness? So for example, even for the sake of it, we say, all right, we'll introduce some percentage of pictures from India also. But that's if that is not more than 10%, then the evenness is not there. So think about all these biases and how you want to measure them and report them on an ongoing basis. Why on an ongoing basis? Because the model is learning and tuning its parameters. So it's not a one-time thing. Then what are the processes deployed in an organization for data provenance? So what does data provenance means here? It talks about verifying the quality of data. What's the number of errors? What about sensitive personal data in here? How do we mask it? How do we remove it? How do we generalize it to whatever extent possible? What are the other errors? What amount of bias is there in the input data? Is it from a trustworthy source or not? So look at all these aspects, have a data provenance model deployed in your organization.